Okay, loud enough, I guess. Great. Yeah, the part about live coding, it's not about programming today, it's about creating a dashboard. And if you have to code for that, something definitely went wrong. With me today is Petra, who's working for Sapient Nitro, and he's going to give a demo afterwards with a little bit more data than I will give today. And I think it's log files, right? Okay, so I think we can skip this one. Anyone not comfortable with English? Too late. Great. Anyone of you are using Elasticsearch? Okay, in production. That's fair. Logstash. It's far less. That's great because I don't have a lot of things to tell about Elasticsearch today. Yeah, what am I going to talk today about is why this talk, why is logging complex, why do we have to think about how we log stuff, how we centralize stuff. I'm going to walk around a couple of examples how to use Logstash, and yeah, I talk about how to scale Logstash, and at the end, which is hopefully not too far away, I'm going to give a short demo, like how to create some dashboard using some live data, HTTP stream, and yeah, so who's talking? My name is Alexander. I'm basically a Java programmer most of my life. Yeah, scary. I've been working with Elasticsearch since 2011, like using it for a product search engine. I've been working for Elasticsearch, the company, since around about a year, mainly developing for the core. Elasticsearch itself features 4 products. 3 of them are open source: Elasticsearch, Logstash, and Kibana. One is a search engine, one is a data aggregation system, one is a dashboard, and the other one has been launched last week, which is a commercial application which basically allows you to monitor your Elasticsearch cluster. Because committing into open source repositories doesn't give you a big amount of money, we need to have other revenue systems which support development subscriptions and trainings, obviously. Okay, that was the PR slide. On to the next. Why do we need to collect and centralize data and log data? The first thing is pretty common in bigger companies, because the operations department and the development department are strictly split from each other, and because developers are stupid, as soon as they log into the live system they will delete all your data. So you definitely have to prevent access to the live system. Another thing is that if you wake up at 3 AM and your server is down, you usually create this huge shell script which parses a lot of dates, has a lot of grep and awk and set commands, and if you wake up at 11 you don't know what you just did in order to find the problem, seeping through the log files. You really don't want to do that all the time. The next step is that if you have a multi-tier application and you create some sort of an exception ID if an error occurs, and you're bubbling up this exception ID to the client and tell the client he can use this exception ID to call the first level support, for example, you definitely need to centralize this kind of information to find problems, to find the stack trace, to find out where the problem actually occurred. And this is a huge need and a huge reason why you actually need to centralize data. And the last thing is reporting, obviously. The thing you don't want to become is your boss grep command or your boss charting library, because your boss jumps into the office and just wants this little tiny number or this wonderful graph because the last day we had a huge amount of orders. He wants to show people. And if you do this once, from then on it's your job to be your boss grep. And this is something you really have to avoid as hard as you can. Another important thing is if you centralize your data from 20, 50, 100, several hundred systems, you are able to detect patterns. And patterns can be different things. Patterns could be that you're able to find out if you're about to be DDoSed because you know there's a surge in traffic. A pattern could be to find out how many traffic you're actually consuming and paying for. And what is really important with this kind of data is that you could actually find out that you need to scale up or scale down very soon in the future. So you actually know things, or you can inter or extrapolate things before they happen. And this is really important if you run on EC2 and want to shut down or start up EC2 instances before like all your other running systems are dying because of the load. And this one is actually not the bonus point one because it's the most important one. Anyone who's taken a look at log files loves exactly one thing: timestamps. Timestamps are one of the greatest inventions ever taken in the world of log files. Let's take a look for the first one. Everyone knows this, it's from an Apache log file, or like most of the common web servers are actually writing out data. And with every request, the time is logged. The first thing is, because you need to group the time, someone had the nice idea of putting it into brackets. Why not? And then it's quite good, because it actually features a time zone, which is quite rare for most of the logging systems out there. And it features an exact date. The other one is the Unix timestamp. Unix timestamp are the amount of seconds since 1970, which is great. But first, it's not very exact, and second, this kind of Unix timestamp can happen 24 times a day because it's missing a time zone. So as soon as you've got more than one system across the world, you actually have no clue when this event has occurred, except when you don't provide additional information like where this log is from. The next one is a standard log4j timestamp, which is quite good because it's more exact than the Unix timestamp, but again, you don't know when it actually has happened. Syslog is even better. It just doesn't give you a year. So yeah, best guess, this year. Then there's a standard, ISO standard. Everything has a standard, dates as well, which is a good idea up to the moment that the standard basically allows you to provide this as a date, which isn't exact either. So this is one of the core problems. And if you wake up at 3 at night and you need to convert timestamps first in order to follow a stream of data across your stack, that's not what you want to do to solve the problem actually. And then there's the last funny part. If you have a localized application and you're writing a date like this works absolutely great in German for the first 4 months of the year, and then it's May, and it's in German M-A-I, not M-A-Y, which means you again have to grab for data which is actually locally dependent, something you really do not want to do. So, and this can happen with any kind of log data you have, but dates are very good and a very simple example of how to show that you don't want to just store data, but you need to pre-process it before storing it in order to make it easily available to search and find streams of data more easily. So, what's the solution? You need to manage events and logs. You need to collect data. This means if you've got a multi-server system with 20 or whatever systems you have, 40, 100, this means you need to have a small process on each server and deliver the data to some central point. This kind of central point then has to parse the data, because with all the different formats we've just seen, like the date, you have to do something first before storing the data, and you obviously would want to enrich the data. So if you have an information like a browser agent or like an IP address, you may want to do a name lookup before you actually store the data in order to know where it came from, or you want to do a geo-IP lookup to actually find out from which country an IP address is. That would be the next step in order to do analytics, for example. And the last part is obvious, you want to store the data and you want to visualize it. If you don't visualize all the data you store, it's basically worthless most of the time, unless you run about it with sort of fancy algorithms. So, if you go on and put this into some sort of Logstash naming convention, you basically have an input where you get an arbitrary sort of data. This can be arbitrary, this can be a text file, this can be a TCP socket, this can be a database or whatever. You have a filter process, which basically is doing all the parsing or the enrichment, and just before it gets to be stored, which is also completely decoupled from an input or a filter, you can specify an arbitrary output. And you can store data, but another interesting thing would be that you need to be notified in case certain events happen. So if there's one exception, which may never happen, and you want to be notified immediately at 3 AM if this happens, you have to define a special output which sends this to your PagerDuty, to your PagerDuty account or something like that. This is more graphical, even more awesome, but it's basically the same as before. What is important is that the input and the output is completely independent from all the parsing and enrichment process. And this is exactly how basically Logstash is working internally. And inputs are quite arbitrary. You can have an input from some monitoring platforms like Graphite, for example, or an SNMP trap if you're into like networking and routing. There are data stores available where you can basically query the data from. But the interesting parts is obviously right now in the logging section, which basically allows you to easily parse log4j files or standard syslog files. A syslog file basically follows a certain RFC, except that every syslog implementation does it different. There's a local possibility, there's a generator, which basically allows you to create test data if you wanted for like load testing with Logstash. And there are a couple of protocols you can use, like WebSockets. Stomp is some sort of extra abstraction on top of WebSockets. Exactly, it's coming from the Java world. And you can also use a couple of protocols. Same basically goes for outputs. You can store data in Elasticsearch, which is my favorite. But you can store data in arbitrary other data stores like MongoDB, Redis, Ryak. You can write notifications, means you can send an email, you can write into a HipChat channel, you can send an SMS or a PagerDuty notification. There are lots of external monitoring services, which are like paid services for like extreme fancy monitoring if you want. And again, you could write to local data, which is pretty useless because usually you have a scaled Logstash system. So, how do you install Logstash? It's pretty simple. All you have to do is to install a JDK first, and as soon as you have a JDK installed and the Java command available, running it is basically no problem. It's a single jar file, which basically means it comes with all dependencies already included. The application itself is written in Ruby, but uses JRuby. And what is important, because everything is packed, you don't have any gem or dependency hell, you don't have to download additional packages after downloading. It just works. There are also Debian and RPM packages, there are also repositories if you want them, and the last one are Puppet modules. So, how does a simple setup look like? This is basically the most simple setup you can think of. The top one is a configuration file, and it defines one input and it defines one output. And this basically means every data you get in on standard in is also written to standard out. We don't do any modification, there's no filter actually, we just write out the data. And the debug is set to true, which basically means the message and all its metadata is written out. And if you do something like echo through on the bash or on the shell, you pipe it to Logstash with this configuration. This is actually the data being returned. What you can see now is that there's a message field which contains the data which has been provided, and there's 3 other metadata fields. The version field is just used by Logstash for internal versioning, which basically means we could change the version and still know or handle different formatting of JSON data. The timestamp field is important for log files, obviously, not if you pipe full into the data, because this is something you can search after. And the host is basically the Logstash host which has processed the data. And what is important is that you can actually use the timestamp, and you can extract the timestamp from the data you just read. Because if you have, for example, a daily import job of your Apache log files, you want the timestamp to be the timestamp when the request actually happened, and you don't want the timestamp to be the timestamp when it was processed. So you have the possibility to set this kind of fields in addition. Also, there's another problem. If you have more than foo in this message, like for example number, when we take a look at the Apache access logs, there's a specific field which basically contains the amount of bytes which have been sent back and forth between client and the browser. And you may want to use this to create aggregations and to sum up this kind of data. You need to extract it because you need to store it as a single number, and you don't want it to be part of the message. So this is basically the next step, that we take a whole message and put it into single fields. There's a question.
Yeah, what's the purpose of the graphics and the version
The purpose is that if you take a JSON document, we're going to that in a second, and it also has a timestamp field, you start overwriting data, but usually most of the data you get in doesn't have an @ prefix. This basically marks it as some sort of internal field. Also, if you have questions, just jump in instead of waiting till the end, and I forgot what I was talking about. So, next step. We're still reading from standard in, we're still writing to standard out, but we're doing something in between. And in this example, we're basically assuming that the kind of data or the kind of event we're receiving consists of 3 fields, and the first one is a word, the second one is a word, and the third one is an H. So if we apply this to data, we see this is the first name, this is the last name, this is the H, and you can actually see that the fields have been written in the data. And this is exactly the reason for the @ sign. If I would want the timestamp to be in, I would need to rewrite the data, which I don't want most of the time. So what does this allow us? If we have the H now in an own field, and we start to store it in whatever data store we choose, we could actually sort by this kind of field instead of just searching the text file. If we go back to the configuration, we see that I used something called a grok filter here. The question is, what is grok? And I think there's only one useful description for this. It's the possibility of maintaining regular expressions for mere mortals. When we go back to our 3 AM case, and you start writing the expression with like 10 different regular expressions, you don't remember it the next day. And this means you need something easy to remember a regular expression. Something like word, which is just the word regular expression, is much simpler to remember than copy-pasting this expression over and over again. And this is basically what grok offers you. It allows you to configure your own patterns without the need to remember the kind of regular expression every time you're actually parsing some data. Yeah, there's a lot of like default patterns, like for Cisco firewalling, for the syslog, for the Apache log file, which saves a lot of time, for the postfix log file. So this is really important, but it's also very easy to write your own patterns if you want. And if you're writing your own pattern, check out this Heroku application, which basically allows you to find out if certain data matches against your patterns. And most of the time, this is one of the filters you're applying to your data, because as soon as you start like integrating your custom data, you will need to write your own like grok patterns to easily extract data from single lines. Yeah, let's take a syslog example with grok. Syslog is some sort of standard logging system under Unix-based systems. Syslog allows you to log data remote over the network, and you can easily read it in. The format is actually also specified by an RFC, but no one takes care about that. And here are a couple of predefined grok patterns again. There's a type called syslog timestamp, syslog host, and there's a posint, which basically means the process ID which is being logged must be a positive integer. And this again saves you from writing your own regular expressions. And then there's of course a syslog message. Here's another tiny little edit filter called date. And this date filter basically uses the field syslog timestamp with this format and puts it into the timestamp field, which allows you to search in the syslog messages for the timestamp when the event actually has occurred, and not when the event has been parsed. If you run this, and we take this as a standard syslog entry, you can see that that's this awful date without a time zone. It has a host where the event actually occurred. There's a process name, and there's a process ID, which is logged, and this is a syslog message. And again, this basically allows you to only filter messages when you're searching in your data which occurred on a certain host in order to find out what may have happened with the system. Or you can just look for connect and search your data when you connect it to another email system. So I've been talking about filters. I just showed the date filter, and I just showed the grok filter, but there are 50 or 60 of those filters, which are for all kinds of different operations. This one might be important if you're starting to parse sensitive data, for example, you never have those around, of course, because you're not allowed to store it, but if you have credit card data, there's a checksum filter, which basically makes sure that certain data has been transmitted correctly. There's a CSV filter, which allows you to split data from a CSV file. There's a multi-line filter, which is important for all us Java fans, because stack traces tend to be a little bit longer than just one line in log files. There's a DNS filter, which basically allows you to do DNS lookups when you're parsing the data, instead of doing DNS lookups when you write the logging files, which you should never do because it's a blocking operation. I just showed the date filter. The GeoIP filter is very useful if you want to look up, or if you store Apache log files, and the GeoIP basically looks up which geographic location the IP address is belonging to. So you can leave this IP address is from Germany, Augsburg, and you can start drilling down your data based on the location of your customers, for example. I'm going to show the JSON filter in a second. There's a URL decode filter, there's a user agent filter, which basically allows you to filter more exactly on the user agent of an HTTP request. So you can actually show data when it makes sense to stop supporting IE7 instead of just hoping it works. There's a metrics filter, which allows you to create statistics over all the log events which have been happening over time. So you can see how many log requests per second you're actually processing with Logstash. And there are really a lot of more, but I think this is a good first overview. And then there's another important thing. This is a new concept which was introduced with Logstash 1.3. It's called Codecs. And a codec is basically something independent from an input and independent from a filter, because it helps you to get an event converted or from or into a certain format. So if you know you have data which is in JSON format, you can just configure Logstash to treat every data from a certain input, like standard in, to be as JSON. And so it gets automatically extracted and the fields automatically put into the field data of Logstash. There's support for a couple of these. I think you might know NetFlow, Codec, and Fluent from a sysadministration point of view. NetFlow is mainly used in Cisco IP accounting. Fluent and Collect are mainly used in system administration, data collecting environments, and message pack and JSON are just simple object notations. Message pack is a very small pack notation of data. So how does it look like? You simply specify an input type, and you specify the codec inside of it. And this basically tells Logstash that every data which is received in standard in is supposed to be JSON data. And if you start to echo data, and you can even put in a new line here, as soon as you discover one complete JSON event, this is going to be passed and the fields are automatically set inside of Logstash for further processing. Then there's a very nice multi-line codec, which basically treats every line as an own JSON object. We will make use of that later in the demo, which basically is really handy if you're parsing some sort of a stream which creates a new JSON event for every data which is being emitted. And you can see here there are two JSON objects which are valid JSON in themselves, and they're both parsed, and they're both parsed as its own event. This is one of the most common use cases of using Logstash. You start using it for analyzing your Apache log files. This basically means that you still would have to use and write your own patterns if you wanted to pass every field into a Logstash event, but there's already a very good grok filter for doing this, so if you don't change your format, it's not an issue. So if you have the original Apache log file format, it's very easy for the grok filter to actually extract all of this information. So if you take a look here, you can see that there's a client IP extracted, that there was no HTTP basic auth involved. That's a timestamp has been written again in the timestamp field without the @sign, which basically means there's something missing, because what you would want to do is that you take this timestamp, convert it, and store it in the @timestamp field again. You can see the HTTP version and the agent. And basically this shows you that you could do a lot more with your data. You could use the GeoIP filter to extract the client IP data. You could use the user agent filter to extract more of this agent info, like to go down on a per browser base. This shows you that this is just a small start with like what you could do with your data. Something which is important to keep in mind, what you're doing here is basically you have a small process on the system where the Apache is running, which needs to send these log files over to your central Logstash instance, which then is doing the parsing. And what you're doing is, first you're taking CPU cycles from the Apache web server to write off this log file, then you're transmitting it, then you're parsing it with the grok filter, which takes quite some CPU, and then you're storing it again. It might actually make more sense to think about if you directly write out your Apache log files as JSON data, because they're easier to parse than to apply a lot of regular expressions on your average Apache log file. This is just burning CPU cycles at the end of the day. Okay, I think slowly we're getting to the time where we want to store data, and I like to use the Elasticsearch HTTP output. You can just specify it, which basically means every data is written to Elasticsearch HTTP. This usually would require setting host name, setting a port, setting an index. There are a lot of useful default settings. If you don't specify anything, everything is written to localhost, which usually is sufficient for playing around with it. So, how does the setup look like? Standard setup in the log file case is usually that you have something called a shipper or forwarder, which is a very tiny, lightweight process running on the host where you want to send the log files to, like the Apache web server. And you can configure it like to just basically tail-f a file and send over everything over the wire to Logstash. This usually works quite well. Logstash then is doing all its processing magic, whatever you have configured, and the next step is actually to store it. Again, I just use Elasticsearch as an example here, because we can use Kibana as the next step to visualize it. This setup has a minor flaw. If this connection breaks, or if the shipper is actually sending more data than Logstash can like parse, you might lose data. And this is definitely not what you want, which is okay with Apache log files, but you might want to parse more sensitive data. So we just move around some squares and then it's awesome. Architecture work. There's a broker in between. The broker can be some sort of data service. I think this is a Redis logo if I'm not mistaken. It can be a RabbitMQ, it can be a ZeroMQ, it can be Flume. It can be something which like queues data for you and which you can just like push more data into. And with this setup, Logstash can actually just query for the amount of data it can process. And this tiny little change basically allows you to easily scale out your whole architecture. This is the first thing you usually have. You have more than one system creating log files. You might have one system with syslog files, you might have 10 systems with Apache serving static data, you might have 100 systems with your WebSphere server, whatever. So you start sending data to your broker. And there might be the time when this is an in-memory queue that you don't have enough memory with one node, so you can just add another set of brokers there. And if you have complex processing steps, like the grok library extracting all the Apache log files, which takes a lot of CPU, you just might want to scale out that as well. And what I left out for like still being able to understand this image that you would possibly need to like use the arrows and combine them with every other component to make it more complex and awesome. Obviously you can scale out Elasticsearch as well. That's what it has been built for. But that's not the point. But this kind of architecture basically allows you to create a really, really nice setup. How does Logstash scale internally? I mentioned it's a JRuby application, so you have some sort of sized queue which you use to move the data around from the inputs to the filters to the outputs. But the interesting thing is how you can change the configuration of it. So each input, you can have more than one input. You can read data from standard in, and you can read data from Elasticsearch, or you can read data from email. That's not a problem. And in order to like not block each other, each input is basically its own thread. You can change the configuration, but you shouldn't most of the time. There's one worker thread, and this one single thread is basically doing all the filter operations. This might be useful, this might be a problem if you have 10 CPUs, but only one worker thread, which is basically extracting all the log file data from your Apache log. And you can change this when you start up Logstash. So you can like basically define a thread pool size for your worker threads. The last part is the output. You can again configure an arbitrary amount of outputs, but the output thread is basically always one. There are some outputs who have their own queuing thread, like the Elasticsearch HTTP output, who wait until they got a certain amount of events and then write them off in a batch process. Yeah, there's a link for this if you're more interested in event handling inside of Logstash. Then is the next step, obviously, how do we visualize this data? But any questions so far to backend stuff? Great. 1, 2.
The log shit, the last time I tried it, it was basically just calling up the job with another parameter. This was eating quite a lot of memory because it's a JVM process and it's not a tiny app as you said, but it's actually quite fat binary, so it's not really recommended on one of these Amazon M1 instances.
Yeah, Java is never recommended on one or another. The thing is, this is usually not a JVM. We have a project called Logstash Forward, which is a tiny Go application. And Go is like threaded and awesome and fast and doesn't have a huge memory footprint. Exactly. Yeah, this, I think it's quite some time ago, and we had exactly that issue where that's a long time in our life cycle. And the shipper is now a small application. The shipper has some built-in features to like queue up data until it gets written if your connection drops. So you don't need a broker at the first case. And it can use encryption. Because usually you have a shipper which is put in your DMZ inside of your firewall configuration, but the Logstash node itself is usually in your internal network. And this means there might be a need for sending the data encrypted. This is also usually a huge finding round with the operations department, I guess. Because you need to basically pinhole your firewall configuration. Okay. So last one.
So the shipper, does it work like a cron job where you say, okay, parse that log file every minute, or could I do something like that K with F?
It's basically a tail minus F. So it's seeking all the time. It's also aware of log file rotation, and you can specify more than one file. You can just specify a whole directory if you want.
But I also could just load data once a day or something.
Yeah, sure. You wouldn't need a forwarder for that.
How many log files can be handled by one shipper or forwarder process?
How many open file descriptors do you allow to your process? See? Now, I mean, the application itself is not memory intensive because it's not building a huge queue or something like that. So it's basically more a resource question of your system. Great. No questions. Okay, this is Kibana. We're going to show it a bit more in a second, but this is one of the classic use cases where someone has indexed Apache log files. Kibana itself is a pure client-side application. It's been written in AngularJS, so it doesn't work with server-based backend. You can see here at the top, someone searched for different file endings. It's HTML, PHP, PNG, whatever, and you can basically see the distribution over time here. This means there's actually a traffic low at 12 PM or night. I think this is a pretty classic graph you see in 95% of your applications if you're not running 24/7 all over the world with the same distribution. This is an interesting one. It's a black theme, right? But apart from that, there's something strange happening because you can actually see by combining all your log files that the moment where you're expecting to have a traffic high, something is breaking. And this is when you should call your system administrator and tell him to fix shit. And this is also the reason why you should have something like this as a dashboard somewhere inside your development department so people can actually see when stuff breaks. In best case, they are obviously notified before they see this image. This is an example that basically shows you that Elasticsearch is not only for log file data. There's a couple of different widgets, like this one is a histogram, this one is a bar chart, and this one is a map. There's just a bunch of widgets. If you want to write your own, feel free to do it. I'm not a front-end guy. And this is just another couple of widgets. This is a histogram again. Here you can see basically some sort of country distribution. And this one is a trending widget, which takes data from the past and data from now and calculates if there's a different amount of traffic going on. Okay, this was Kibana. We're going to see it in a second anyway. There's a couple of useful helpers. There's something called curator, which is important when you're basically storing time series of data. Usually when you have a huge amount of log files, you have one index per day. This basically means you're storing data on a daily basis. You have one data container for Monday, Tuesday, Wednesday, and the 4th for each day. And you need to clean this stuff up. This means you basically need a cronjob, which starts cleaning up your data. This tool allows you to just provide some sort of data retention policy, which is then applied in a nightly cronjob. But it's just a couple of lines of Python script, so it's nothing big and fancy. The Puppet module might be interesting for you. The Logstash forwarder was the lightweight process I was talking about, so if you search something for like centralizing your logs, you should take a look at that one. And there's something called the Logstash cookbook, which contains a couple of standard recipes which you could use to like get up and running, like how to index your Apache log files, how to index syslog files, and how to make this in the most efficient manner. So if you're interested in starting with it, the cookbook just gives you a couple of recipes you can definitely use. Okay, I think we can start with a small demo. Are there some questions while I'm preparing?
I met some people who are doing the following thing. All the log files were normal analyzing through Elasticsearch or other kind of, let's say, fast analytic tools, and most of the things are archived in Hadoop or HDs. Just for analyzing, for example, comparison between weekly data, monthly data, or previous data. Is that also you find as from your experience as being useful, or?
I can just go with the classic consulting answer here. It highly depends. I would not introduce Hadoop if I didn't have this for this use case. If you already have it in your stack and you want to use it, it might make sense. But the question is, do you want to do some additional post-processing with your log files, like seeing and matching patterns, which, this is the point when it makes sense to store it in Hadoop in order to like execute further MapReduce jobs on top of it. If you just want to store it for the possibility of storing, you can do it in Elasticsearch as well.
For storage, for example, for a larger time scale, not for 1 day of loss, for example, or 1 month of loss. Something like exactly what you said, finding a pattern.
I mean, if you try like running machine learning algorithms on top of that or something like that, it definitely makes sense to store it.
To the Hadoop question, sort of further in that direction, Elasticsearch allows also several backends. There's file system, Hadoop. Is there any preferred, or what's the most efficient, or is there any variables which influence what backend you choose?
That's not 100% accurate. So the first thing is Elasticsearch stores its data always on the file system at the moment. You can configure HDFS to store snapshot and restore stuff, which is basically some sort of backup functionality, which is coming in Elasticsearch 1.0. But this is only for the kind of backup data you're generating. This is not for the live data we are using to search on. Then there's a second thing, which is called the Hadoop integration, which basically allows you to execute highly config jobs inside of Hadoop, but the queries are actually executed against Elasticsearch to provide faster answers. But again, this Hadoop integration basically duplicates your data into Elasticsearch to provide fast queries. Make sense?
If I don't want to set up all this infrastructure myself, do you offer any turnkey solutions online so I can just add an appender to whatever logging
few times on this, so this is right now nowhere near the scope of what we are able to handle. There are a couple of companies which provide hosted Elasticsearch, which you could try out and see if it works. I am not sure if there's actually a company providing hosted Logstash. I read something about that a couple of days ago, but I don't think they are live yet. So.
No, because you get competition. You get logentries.com and a couple of others that are really super easy to use to solve that. And so I was really surprised I haven't found anything for Logstash in that space.
Yeah, right now it's not in the scope of our task to provide a hosted solution. So this is a lot of work from the maintenance perspective. Great. So I'm preparing this display screen. Is this big enough for the people in the background, or we have to go bigger? So, the first thing we need to do is start with Elasticsearch. Always bleeding edge. Again, Elasticsearch basically works similar to Logstash. You need a JDK, you need to download Elasticsearch, you need to unzip it, and all you have to do is to start Elasticsearch with this one single command. And there's also a batch file for Windows if you're like keen to use it there. What we can see now. This is basically a small plugin which is really glad to recognize. I can see the word. So this is a small plugin which basically shows you the kind of data you have inside of Elasticsearch. And because I got internet access, I can basically delete all my data I have, and we just close it for a second. See, deleting data is always easy. The next step is that we is to take a look at the kind of data we want to index. So always put the examples in download Logstash samples. This is a stream from meetup.com, which basically writes out JSON data. And every reservation you're doing on meetup.com is written out in this stream. They provide it as public data in order to decide whatever you want to do with this. So let's take a look at what kind of JSON we actually indexing, or want to index. So this is a kind of JSON which is supplied by the meetup.com stream. So there's a member which basically just created a reservation. There's an event with a name, time management, awesome. There are a couple of topics like sort of keywords which are being indexed. And there's a venue with the latitude and the longitude, which obviously is a good idea to graph it later on the map. So this is the kind of data we want to index. So I created this configuration site because there's no HTTP input for Logstash. You can basically just stand it in, and we are just going to pipe the curl output over to Logstash and use the standard in. Then we are doing some filtering. This is important because we need to change the data structure for the map widget I'm going to show in a second. Basically, it needs an array which consists of the longitude and the latitude in order to graph this data. We create some metrics, which basically allows us to index data to see how many requests or how many reservation requests per second per country have been happening. So you can see like the US are executing 3 reservations per second or whatever. And we set up a couple of outputs. So if this is a metric, I'm going to write this to standard out. And if this is a metric, I'm going to write it into the metrics index. But if this is a meetup, I'm going to write it in the meetups index. And this is just so I can use the meetups index in a second to visualize and draw my data. So if we start this with the meetup configuration we just saw, and you forget that you wanted to curl the endpoint into it, we can just take this. This takes a second because the Logstash jar is actually 80 megabytes, and the JVM is not the fastest thing to start ever. But yeah, you can see here that Logstash now started. If we look here, we see in Elasticsearch that meetups index has been created. This basically means that we already started indexing some meetup data. And you can see here in the graph before that the meetups index has been created. Basically, lots of data. If I now take a look at the search index, which is not formatted, here, we can basically see. Just show the single entry. This is basically the same data we just saw in the command line, but it's now indexed into Elasticsearch and can be used for searching. So now you see that the metrics index has been created as well. So we start to get the metrics of the reservations itself, and our next step is obviously to create some nice fancy dashboard. So what you can do is bigger. So you can download Kibana, which is basically just a zip archive. You can unzip it. It contains all the HTML files. And the next step is to create an HTTP, or to start an HTTP server to serve these files. And there's a nice Python class which actually just starts the HTTP server for 8000. And now you can check out all 8000 and you see this big application. And we want to start with a blank dashboard. So now we can start creating our own dashboard and start to analyze meetup.com data. The first thing is we have to specify a dashboard name, which is meetups. We have to specify an Elasticsearch index to read the data from, which is meetups. Let's see here, that's the one. We want to preload fields, which gives us some sort of suggestions when we are specifying certain fields. Then we want some rows, so you can specify rows inside of your Kibana dashboard. The first one was an overview, and it should have a certain height. The second one is going to be our map widget, which is higher. And the third one is just an overview of our entries. So now we are done setting up the basic layout of the dashboard. The easiest part is the last one, which is a table, and the table basically lists all the entries which match your query. You can configure a span here. You might know that from Twitter Bootstrap, so you can configure a span of 12, which basically takes the whole width. That's it. Save. You scroll down, and we can actually see the first index data. And the thing is, we're just searching for all of the data. We'll change it. So JavaScript. And we can see, hopefully, that there's a JavaScript study group where some people reserved in the last couple of minutes when they started indexing data. Because this is not the nicest view, we can actually specify some single columns. We want to know which city this event is happening in which country. And this allows you to at least drill down on single entries if you take a look at the data. So the next step would be to basically get a time-based view of the data, which is a histogram, which might have a little bit late. It's still an overview. And we just save. This looks a bit strange. Time filter from the last 15 minutes. You can basically see when I started indexing data. It's a bit sparse because we still have this filter from the JavaScript going on. If you remove it, you can see it's basically everything is updated in real time. Also, you can see that this is not anymore just JavaScript meetups. Basically, everything is wired together. So this is totally spectacular, but we still want to add another panel. I think the pie charts are totally useless. I think they're awesome. We want the distribution by country. And we can just search the country. start like creating aggregations over this field. And it allows you to see that meetup.com is a like pretty US-heavy service actually, because 75% of the reservations have been done in the USA or from the USA. So if you're just interested in like German data, we could like country correct filter for me. And we can actually see that there have just been 3 reservations since we started mixing data. Yeah, it's midweek music, really fun, and it's Latin quarters, and no tech stuff so far. Okay, this is a quick overview. The last one is like adding a map panel. There's something called map and better map. Naming is not the greatest thing in IT ever. We want to show the location as a title. And this is where the long left field I was mentioning a couple of minutes ago kicks in. There's a tooltip field, which I think doesn't work right now. Then I need to show. And just save it. And you can see the distribution of events across the globe of the meetup reservations which came in. So it's pretty neat and easy to actually create the sort of standard dashboard. Again, you can like start filtering for JavaScript, typing, and you can basically see no JavaScript reservations so far in Europe, at least not Germany, sorry, I think one definitely belongs to Europe. Yeah, that's so much about my quick introduction. And I think Petro is going to show us his log file analysis with like a bit more of data. And while we're reviewing, feel free to ask a question.
Just one short question. When you're doing this filtering, for example, from a tag, can you do some sort of, let's say, preferred search? If you would like to find the JavaScript for certain field, then it should be, let's say, appearing as first rank and other search on another field. For example, so this is alternative.
You want to score it per field.
So it's like I would like to, let's say, put one field ahead, so like ranking the fields which contain JavaScript. So for example, if I had to search for a document, I'm not saying perhaps for document, I would like to have first of all rank according to the title of the document, and afterwards the chapter of the document. And afterwards be filtered inside the text. So is such a thing possible with Elasticsearch? Or
it's possible with Elasticsearch, but not with Kibana. You can do more custom scoring inside of Elasticsearch, but Kibana, because it tries to be as generic as possible, does not like offer this kind of functionality.
There is other kind of integration tool for Elasticsearch, which is capable of doing the rank.
I think it's so custom that you would need to end up writing it yourself anyway in this case. It's really deeply custom, and it doesn't make a lot of sense from our point of view to provide this kind of specific functionality in its own app.
Just a short question. As I understood it, everything you did with Kibana was just in the browser?
Yeah.
And if you want to reuse your dashboard or distribute it or something?
That's the great thing about it, which I totally didn't show. Because you're reading out of an Elasticsearch index, you can just store the Kibana dashboard inside of it as well, and then share it with others. So you have load safe mechanisms, you have a share mechanism which basically allows you to provide some sort of read-only dashboard for your boss, so that it doesn't modify it. This is just possible because we just store it in Elasticsearch as well.
Is it possible to have any differentiation between users, where if you've got 20 users all writing their favorites into the storage?
You can have your own custom dashboard per user. You can have your arbitrary amount of dashboards.
Can I secure meetings for special people or groups?
No. Yeah, the thing with security is
Security is enterprise this morning.
no, the thing is either you do security right or you don't do it at all. And so far till now we decided to not do it at all. There's a long-term roadmap, let me phrase it that way. Period. I mean, this is a feature which might come sooner or later, but right now we can like tell people we have it ready by then, or we plan to do it right now. We know this is an open issue, but we still need to think a lot about different things. It's not about user, authorization, authentication. It's about encrypting transport communication between Elasticsearch nodes. There's a lot in this equation, and this needs to be like thought well through before like compromising security or performance. And so we move it away as far as possible.
Do you have to prepare Elasticsearch for using with Kibana, like adding indices, special mappings like this?
That is something Logstash does, adding a special mapping. But you don't, like I just showed. I deleted all my indices before I started doing the demo.
For production use, you have to tweak it.
He's now talking about production, I'm talking about the shiny world, and he's talking about the real world.
So I'm going to show you your real production system with this Logstash Kibana and of course Elasticsearch. And at the beginning, I started the same like on the test machine, just power up Elasticsearch, send some logs from Kibana after 2 days.
You use microphone. You use microphone.
It's behind the mic.
Yeah.
And you have to switch on.
Okay. So we'll go directly to my board here. We're a web agency, so we're producing websites, and one of the products we're using is the well-known Adobe CQ. It's a Java app, and it's producing a lot of errors and lots of exceptions. So it's a good showcase for storing this into Elasticsearch. What I'm having here is kind of 7 days of logs from around 20 machines, and it's already 75 gigabytes of data. And everything is stored on one Elasticsearch node on one machine, and it's running pretty smooth, but it needs to be tweaked. So as I said in the beginning, I just started up like that and power some data. No, it crashed after 2 days. And this is, I'm doing everything with Puppet, the configuration, and these are the most important configs for the Elasticsearch YAML file that need to be done. So,
can you zoom in?
Can you share?
How can I zoom? Okay, anyways, I think there's a good blog post on the internet about this. You can find it like searching for big Elasticsearch for Logstash. Let's go back to your Kibana installation here. So this is the default dashboard, and I'm seeing, let's say, last 12 hours of logs. As you can see, it renders very fast. And these are the fields that Alex showed. We can have the timestamp, the message, and the multi-line to filter. I will show you here a real example from the problem with these fields here is it's searching only on these events that are available here. You know. It's a nice Java exception. So it was with a multi-line filter in Logstash. It just shows as a single event, so it's easier for you when you search. The search field is very fast, I would say. I searched the logs for the last 20 hours, 24 hours for the util class. So it's almost instant. It's slow today. 32 cores CPU and 32 gigabytes of memory in this server.
And how many data are you ingesting per day?
Well, it's around 10 gigabytes of data every day, and you know it's compressed. It's going by default. One of the questions was how you can store your own views here. So it's very easy when you create a new dashboard. You save it here, and you can load it just with one click.
Are you sure you VPN link this up? Are you sure you VPN link this up? Because this is all one-page application from the browser.
Yeah. Oh, the default one should be showing something. It's always during the demo, it's not working. I hope it didn't crash. For sending the events from one of the servers, I'm using Beaver. I'm not using Logstash because Beaver is smaller, you know, it's not using that much memory.
So the server that you're running Elasticsearch on, you said that had 32 cores and 32 gigabytes? Okay. And do you find that it's running at capacity, or is there some room to spare if you have more logs to store on storage?
Not that big.
Are you running Elasticsearch and Logstash?
Yeah, on the same system. And the Logstash is parsing everything here. So I'm not doing any filters on the host that sent the file. So yeah, it showed up. So, questions? I don't know what to show. Let's load the data for the last 7 days. I have to say this is a out-of-the-box installation. I did it in 2, maximum 3 days, so it's not very quick, but still you can have a good installation very fast. So count 1 hour at the maximum here. We have more than 250,000 events.
So do you also use Elasticsearch indices to actually look at things for bug fixing and stuff like that? Do you use queries on your Elasticsearch index
show me all messages between 2017 and 2018 today.
Exactly
So you
for
find
this.
that to be very responsive.
It is because when you're trying to search some logs, you will not search for the last 7 days. You'll search for the last 5 minutes, and for that it's pretty fast. I work in operation, and my colleagues from development, they always ask me, "Hey Peter, can you provide us the latest logs from production or from one system?" Okay, it's just SCP, send them over Skype link or something like that. And in the end, I had to install this, and it's very easy for them. Could you point us to that? And I just show them a dashboard, and they search it for themselves there. I don't know why is it so slow today, but yeah, it was much faster. I think he's still trying to do the latest operation.
Any other questions in between? Kibana, Logstash, Elasticsearch.
What is the best file system to use for?
Sorry, I didn't get that one.
What is the best file system to use for Elasticsearch?
Usually people run with X3 and X4 and 17 edition. What you should do is running on top of NFS, because Elasticsearch is giving you a scene under the hood and you get problems with file locking. This also means you can't run it on the cheapest net files. Well, apart from that, it should have an issue.
I read something about when you delete documents that they're only marked as deleted and not actually deleted.
That's 100% accurate.
What's the process for
okay, so
removing 50% of your data?
Now, the reason for this is simple. Lucene is using something called immutable file segment. So whenever it writes data, it never touches this data again. This means there's a continuous stream of data which gets written into blocks. The nice thing about this is that the operating system can use this chunks of data and put it in the file system cache. And this is blazing fast. This is like having no read access because the file is in the memory. But this makes it complex when deleting data. So when deleting data, we are not like seeking on the file system, removing the data and going back, because this would mean changing an immutable file segment and thrashing the file system cache. But we are marking it as deleted, and then there's some background process going on every now and then, which basically removes it and rewrites the segment so it can go back into the file system cache. But that's the main reason for it. We get a lot of performance out of that. And we don't have to do anything for that because it's the operating system. That's the great part about it.
And when does it get deleted, or how do you permanently delete it?
There's a process called merging, which has some sort of policy, like after so much data is marked as deleted inside of one immutable data structure, or a certain amount of time is passing by. And you can configure that, but we usually know it's quite same defaults, and that's a background process. So it's not triggered by an index or delete operation, at least not by a single one.
You can see here Logstash crashed or it was slow processing all the logs from the last 2 minutes. You see on 2022, from 2022 I had nothing, 30 seconds ago and now it processed. So I guess it's doing something.
Okay, further questions?
Can you store system metrics on Elasticsearch? I mean, Logstash and Kibana is suitable for this. System metrics like CPU and SQH and memory usage stuff. So really low-level stuff which produces a lot of noise.
When do you think this project?
Does it make sense? That's the actual question.
I mean, the question is always, I mean, in my opinion, it only makes sense to store data if you query it together. The thing which drives Elasticsearch is that it's as easy as possible to get the data out of it. And from an Elasticsearch point of view, it doesn't matter if you store a whole book there or just a tiny little metric. We have customers which are storing traits there, which is just a couple of bytes. We have customers which are storing books using Elasticsearch. So this is just the use case issue.
But it's probably doesn't make sense to vary. But what about correlation? It could be useful to have it for correlation between application metrics and in order to see when, for example, I don't know, out of memory error occurs, what happens with your data, what happens with your solids and such stuff. So,
but you store that in a monitoring system like Sense or I don't know, and you can correlate that with your data in Kibana that you're getting from your logs. I don't think it's anything that comes from Logstash input field can be used.
Kibana itself always gets its data from Elasticsearch. And Kibana just fires on certain queries. So, and there's no other component around right now which understands the Elasticsearch query DSL. And Kibana can only extract data from the data store which supports Elasticsearch.
Okay, so for example, can you combine data from Graphite and from Logstash?
Yeah. One of the input plugins is Graphite. Here we can send directly the data from Graphite into Logstash.
What does that exactly? The Graphite plugin. I mean, it just pulls data and stores it in Logstash.
Yeah.
Well, this is basically not what you normally want. You want to overlay your system charts with the CPU and disk usage and whatever with your current logging stuff.
Well, then you have Ganglia, let's say. You collect the data with Ganglia and you send it to Logstash.
I mean, it doesn't make a lot of sense to duplicate the data if you already have a completely furbished Graphite dashboard.
Yeah,
Graphite allows you at the end of the day to monitor simple metrics like the CPU average or whatever. But you can't monitor your stack traces and exceptions and expect them. You would need to write an additional Perl script to do this kind of Graphite logic.
So there's no dashboard utility.
And there's no integration.
From the Elasticsearch point of view, what is the failover strategy, if there is any?
What is your failure?
I mean, it's a storage, so is there any failover strategy for that?
Yeah, for sure. So usually Elasticsearch is a distributed and scaling system, completely buzzword compliant. The basic strategy behind it is that if you create an index to store data, you can define how many copies of your data you want to be available inside of your cluster. And you just define how important this data is, and you can tell it be available on every node, or just be available on one, and if that's not precious, I don't give a shit about it. So, yeah, at the end of the day, you are responsible and you have to define how important your data is and how securely or how much replication should be going on.
Replication is master node or not?
There's always, we take an index and we divide it into pieces, which we call shards. And every shard has a primary shard. But the primary shard is not running on the master of the cluster, it's distributed. And if that one fails, another shard, which is just a Boolean flag, becomes a primary shard. And the data gets written to the primary shard first and then replicated, and only if the replication was successful, the write operation is considered successful and returns to the client by default. You can change this in a lot of ways. You can really completely change the default behavior, but this is what we do by default in order to ensure that the data gets written.
With your sending process, you use something else to send data. You don't Logstash, something else.
I'm sending with Beaver to Redis, and then I'm reading from Redis with Logstash and putting it into Elasticsearch. Elasticsearch.
If you have data available in some millisecond resolution, is Logstash as a template set up to deal with that?
I'm not sure if I get the problem. I'm not sure if I get your problem, which is
if you have data with if you have your timestamps in microseconds.
Yeah. You basically store it as a log.
Well,
just press command plus, please. Maybe it doesn't. So it's basically a timestamp is by default a Unix timestamp, but it's just a number. And if the number is longer than other ones, you just need to keep that in mind for calculations, but that's it. It's just a number. And the date is just a specific number.
Yes,
this was like milliseconds, so you could expand this to microseconds.
Yeah.
Can you extrapolate from the Elasticsearch to MySQL or something else?
There's an API which basically allows you to seek over all data, like some sort of export process, and then you can do what you want with it. Yeah. That would be some sort of Python script or whatever.
Everything is stored in JSON, Elasticsearch.
It's all JSON at the end of the day. If you can pass JSON, everything else is easy.
If I use some kind of MongoDB like in source, can I do some aggregation? Can like introduce it to that yet? It's not like raw data, but like introduce it beforehand?
Not inside of Elasticsearch itself, but you could use this kind of backup process I just mentioned to then trigger another kind of this map reducing action and then store it again.
So it's flexible enough to map reduce without the aggregating data for that. Okay.
So I'm still a little bit stuck on that answer of not saving Elasticsearch to HDFS. A lot of the concepts that you're explaining are about replication and other things, sharding, that are available in the ecosystem. Does it make sense to try to store HDFS directly, or is it not something that should be considered?
Yes and no. Yes, because with Elasticsearch 1.0 to release those. Yes and no is the answer. The yes part is with Elasticsearch 1.0 we have something called snapshot and restore, which allows you to easily create backups, which is important from a sys administration point of view. No, because we still see possibilities to improve the writing of data and make sure it gets written as we expect it to be, to add additional consistency checks. So we know we can improve there. We still have customers and we still have partners who say you can use it as a primary data store if you want. But from our point of view, we can do additional steps to ensure this.
But it makes it difficult to co-host it in a Hadoop HDFS environment.
Not really, because you can run the Elasticsearch Hadoop integration on the same nodes, because they need different resources.
But you have to dissect your plates, your disks, and make sure that there's enough for Elasticsearch, and you have to make sure that HDFS doesn't take that space.
Yeah, you have to make sure you got enough space, right?
So it would be easier from an operations standpoint to just dump it all into the same thing.
Sure, but I mean, if you want to store a lot of data using HDFS, but you still won't be able to query it fast, you might have to bite the bullet and store it twice. There's no
that's
like.
what I want to do.
Yeah.
Because if we talk about terabytes of data, then that's not fun.
Yeah, terabytes not that much, but it's still you have to take a compromise. Either it's space, either it's execution speed, and if you're not willing to do this, you have to bite one bullet.
So that's the question actually. Is there something inherently preventing the storage of HDFS? Is there a performance degradation point?
Yeah, from our point of view, the Elasticsearch Hadoop integration is faster in querying data than the HDFS integration. This is the whole reason why we're rolling. And not a bit faster, but a lot faster. Okay, so think last question.
So, do you think other kind of search solutions now not different 100% plugins, but the search capabilities. And then something like Solar and something very similar to that, whatever. Is that nowadays some sort of benchmarking which is best of this two setups, or regarding Elasticsearch or this other stuff on AWS?
I don't think it's wholly about benchmarking. It's about ease of use. It's about how comfortable you feel with the solution. Speed is an important issue, but it's not the only one. There are differences to Solar, there are differences to other data stores, and you have to check if this one fits your use case or not. It's not like there's some sort of Excel sheet where I just check off the requirements and everything works. Search is too complex for this. That's a tough thing. You have to try it out yourself. Okay, I think we're going to break up for beers. If you have questions, go to Peter or me. And apart from that, have a beer. Thanks.